Hello everyone, welcome to chemistry classes. So today we will discuss about the batteries, the next concept of this topic, electrochemistry, batteries. So in the previous video we have discussed about the product of electrolysis clearly. Now we are going to discuss about batteries or battery technology. And so we use batteries for our everyday life, okay? For energy we use that as a energy source. We use batteries for torches, batteries for remotes, isn't it? So those all the batteries we are going to study about those batteries in detail, okay? So such type of batteries we use, isn't it? So we'll discuss about them in detail. So firstly, what do you mean by battery? What do you mean by battery? In this topic we have learnt about we can convert electrical energy into chemical energy, isn't it, by using electrolytic cells. And also we can convert chemical energy of a reaction into electrical energy. So the best example for that is galvanic cell. In galvanic cell we use two type of electrodes. So those electrodes are called as half cells, isn't it? So the combination of two half cells form a cell. The combination of two half cells form a cell. The combination of large number of cells in series called as a battery. So battery is nothing but it is just a combination of a large number of cells connected in series. That is called as a battery, isn't it? So battery andre ಏನಂತಂದ್ರೆ ನಾವು ಈ ಎಲೆಕ್ಟ್ರೋಕೆಮಿಸ್ಟ್ರಿ ಟಾಪಿಕ್ ಒಳಗೆ ಕಲ್ತೀವಿ, ಗ್ಯಾಲ್ವನಿಕ್ ಸೆಲ್ ಅಂತ ಕಲ್ತೀವಿ. ಗ್ಯಾಲ್ವನಿಕ್ ಸೆಲ್ ಏನು ಕೆಲಸ ಮಾಡುತ್ತಂದ್ರೆ ಕೆಮಿಕಲ್ ಎನರ್ಜಿನ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ ಕನ್ವರ್ಟ್ ಮಾಡುತ್ತೆ. ಹೌದಾ? ಆ ಗ್ಯಾಲ್ವನಿಕ್ ಸೆಲ್ ಸ್ಟಡಿ ಮಾಡುವಾಗ ನಾವು ಏನು ಸ್ಟಡಿ ಮಾಡಿವಿ ಅಂತಂದ್ರೆ ಆ ಗ್ಯಾಲ್ವನಿಕ್ ಸೆಲ್ ಯಾವ ತರ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಮಾಡಿದ್ವಿ ನಾವು. On the left hand side we have taken zinc electrode, right hand side we have taken copper electrode. ಹೌದಾ? ಸೊ zinc electrode ಗೆ ಆಕ್ಸಿಡೇಷನ್ ರಿಯಾಕ್ಷನ್ ಆಗ್ತಿತ್ತು, ಕಾಪರ್ ರಿಡಕ್ಷನ್ ಆಗ್ತಿತ್ತು. Zinc electrode is used to called as oxidation half cell and the copper electrode is used to called as reduction half cell, isn't it? So the combination of two half cells form a cell. ಎರಡು half cell ಗಳನ್ನ ಕಂಬೈನ್ ಮಾಡಿದಾಗ ಒಂದು ಸೆಲ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಆ ತರ ಸೆಲ್ ಗಳನ್ನ ನಾವು ಸೀರೀಸ್ ಅಲ್ಲಿ ಕಂಬೈನ್ ಮಾಡಿದಾಗ we are going to get batteries. Okay, so a battery is an arrangement of electrochemical cells. A battery is an arrangement of electrochemical cells used as energy source. Why we use them as energy sources. A useful battery should be light. Useful, if the battery is said to be useful, it must be light. The weight of the battery must be less and it must be compact. It must be lesser in size. If the battery can produce a lesser amount of energy, if the size of the battery is this much, what is the use? If it produces 0.5 volt of energy and 0.5 volt of voltage or potential, the size of the battery is this much. Is it possible to use for remotes? No. Okay, it must be light, it must be compact, and its voltage should not vary appreciably during its use. It's important. This point is most important. Why? Because here, if a battery is said to be a good battery, its voltage should not vary during its use. ನಾವು ಬ್ಯಾಟ್ರಿಗೆ ನಾವು ಬೆಸ್ಟ್ ಬ್ಯಾಟ್ರಿ ಅಂತ ಕರಿಬೇಕಾದ್ರೆ ಏನು ಕಂಡೀಷನ್ ಅಂತಂದ್ರೆ ಆ ಬ್ಯಾಟ್ರಿನ ಯೂಸ್ ಮಾಡುವಾಗ ಅದ್ರ ವೋಲ್ಟೇಜ್ ಅಲ್ಲಿ ವೇರಿಯೇಷನ್ ಆಗಬಾರದು. ಹೌದಾ? ಸಪೋಸ್ ವೋಲ್ಟೇಜ್ ಅಲ್ಲಿ ವೇರಿಯೇಷನ್ ಆದ್ರೆ ಏನಾಗುತ್ತಂದ್ರೆ ನಾವು ಯಾವ ಪರ್ಪಸ್ಗೆ ಬ್ಯಾಟ್ರಿನ ಯೂಸ್ ಮಾಡ್ತಿರ್ತೀವಲ್ಲ ಅದ್ರ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ನಾವು ಯೂಸ್ ಮಾಡುವಂತ ಮಟೀರಿಯಲ್ ಡ್ಯಾಮೇಜ್ ಆಗುವಂತ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. ಸೊ ಬ್ಯಾಟ್ರಿ is said to be a good battery, it must be light, it must be compact, and its voltage should not vary appreciably during its use. Next, in batteries generally there are two types. In batteries there are two types. The first one is called as primary battery, second one is called as secondary battery. ಬ್ಯಾಟರಿ ಅಲ್ಲಿ ಎರಡು ತರ ಇರ್ತವೆ, ಒಂದು ಪ್ರೈಮರಿ ಬ್ಯಾಟರಿ, ಇನ್ನೊಂದು ಸೆಕೆಂಡರಿ ಬ್ಯಾಟರಿ. ಹೌದಾ? ಸೊ ಲೆಟ್ us discuss about them one by one. The first one is primary battery. The first type of battery is primary battery. Why the battery is called as primary? Let us see that. A battery in which reaction occurs only once. In a battery, the reaction should occur only once in its lifetime. After using over a period of time, battery becomes dead. In a battery, the chemical reaction takes place only once, and after using that battery for limited period of time, over the period of time, the battery becomes dead. After the completion of chemical reaction, battery doesn't supply or it no more capable to give energy, means that is said to be dead and cannot be reused. That cannot be reused. Such battery is called as primary battery. So this point is very important. The battery is said to be primary. In the primary battery, what happens? A chemical reaction takes place only once, and we can use that battery for a limited time period, isn't it? So after that, what happens? The battery becomes dead, and that battery cannot be reused. That battery cannot be reused. If the batteries cannot be reused, that is definitely a primary battery. That battery is called as a primary battery. The best example is dry cell. The best example is dry cell. What is dry cell? See here, you all used that dry cell. So these are nothing but dry cells. They are called as dry cells or Leclanche cells. This is called as dry cell or Leclanche cell. Nippo batteries, isn't it? So like that, those all batteries are dry cells. And so let us discuss about dry cell. What is a dry cell and how it is constructed and what is the working of dry cell? Okay, so here I try to give it pictorially. Let us assume this is the dry cell. Here ಈ ಡ್ರೈ ಸೆಲ್ ಏನು ಮಾಡಿ ನಾನು ಜೂಮ್ ಮಾಡಿ ಬರೆದಿನಿ ಅಂತ ಹೋಗ್ಬಿಟ್ರೆ ಡಯಾಗ್ರಾಮ್ ಅನ್ನ ಅಷ್ಟು ನೀಟಾಗಿ ಬರೆದಿಲ್ಲ, ಸೊ ಸಾರಿ ಫಾರ್ ದಟ್. ಸೊ ಇದು ದಿಸ್ ಇಸ್ ಅವರ್ ಬ್ಯಾಟ್ರಿ. ಸೊ ಈ ಬ್ಯಾಟ್ರಿ ನಾವು ಏನಾದ್ರು ಓಪನ್ ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ ಓಪನ್ ಮಾಡಿದ್ರೆ ಏನು ಸಿಗುತ್ತೆ ಅಂದ್ರೆ this battery is consisting of a carbon rod or graphite rod. At the middle you might be seen that at the middle of the battery there is a black colored rod. That rod is called as graphite rod, and this rod behaves as a cathode. That rod behaves as a cathode, and this battery is enclosed with a zinc cap or zinc cup. Here the covering is made by zinc. Can you see this zinc? This is zinc. So in the battery at the middle there is a graphite rod, and this is covered with zinc cup or zinc can. So this zinc can behave as anode, and the middle graphite rod behave as cathode, and the space between the cathode and anode is filled with electrolyte. So the electrolyte filled here is the paste of ammonium chloride, carbon black, carbon powder. Carbon black is nothing but carbon powder, and manganese oxide, MnO2. Here the space between anode and cathode is filled with electrolyte. So this is our electrolyte. So what is the electrolyte? The mixture of MnO2, carbon black or carbon powder, and ammonium chloride paste, isn't it? So this behaves as our electrolyte. So if you open this battery, what happens? We are going to get black colored powder. That black colored powder is nothing but it consists of large amount of carbon powder. With that, manganese oxide and ammonium chloride pastes are present. See here, at anode the chemical reaction taking place in this battery at anode is zinc is oxidized. Do you remember, at anode always oxidation reaction takes place. So the zinc is oxidized at the anode, means at the zinc area, means around the surface. What happens? Zinc is there, zinc is present, and zinc undergo oxidation. Zn gives Zn2 plus 2 electrons. And cathode, which is cathode, this graphite is our cathode. At cathode, here the electrolyte undergo reduction. MnO2 NH4 plus. So this NH4 plus and MnO2 undergo reduction to give MnOOH and ammonia. Here this NH4 plus is reduced to give ammonia, and this is manganese oxyhydroxide. This manganese oxyhydroxide is also formed here. The oxidation state of manganese here is +4, isn't it? So how it is +4? Oxygen is always -2 into 2 -4. X minus 4 is equals to 0. So X is equals to +4. So the oxidation state of manganese is +4. Here what is the oxidation state? OH is -1, oxygen is -2. So obviously this is +3. So it's not +3. Okay. So let us calculate this. X minus 2 plus -1 is equals to 0. X minus 3 is equals to 0. x is equals to plus 3. So plus 4 is converted into plus 3 here. Plus 4 is converted into plus 3, and here from ammonium ion, ammonia is produced. From the ammonium ion, from the paste, ammonia is produced. So this ammonia react with zinc and it will form this ammonium ions. This ammonia will react with zinc and it will form a complex compound. The ammonia formed in the reaction will react with zinc and it will form complex. This tetraamine zinc complex is formed. Tetraamine zinc chloride, I think it is. So this complex is formed when the reaction is complete. Reaction complete means when the amount of this NH4Cl present in the battery is exhaust, means all the ammonium chloride is converted into this compound, this complex, the battery is said to be dead. So because of that reason, the dead batteries have what? Ammonium smell, ammonia smell, isn't it? Okay, so this is about the dry cell, the first example of primary battery, and the voltage of this battery is around, the potential of this battery is 1.5 volt. So in each and every cell they will mention the voltage as 1.5 volt, 1.5 volt. So you can see any battery, they all are of around same voltage, 1.5 voltage. Okay, and even your mobile batteries are also belongs to this type. So not this type, they are also belongs to this type of batteries, but they are not primary batteries. Their classification is different. Okay, next, the another example of primary battery is mercury cell. The another example of primary battery is mercury cell. So what do you mean by mercury cell? So do you know the batteries which are present in the calculators and watches? So this type of batteries. So these batteries are called as mercury cells. These are called as mercury cells, isn't it? So why they are used? So these batteries are used for a large energy source. They are used as a large energy source. If we want energy in smaller amount, we can use this type of batteries. Okay, mercury cell. So this is suitable for low current devices. This battery is, this mercury battery is suitable for low current devices. The devices which needs low current, for them we can use these batteries, like watches, calculators, hearing aids we can use for them these type of batteries. This battery consists of zinc amalgam. This battery consists of zinc amalgam. Any element with mercury formed as, we can call it as amalgam, not a bubble gum. Okay, so zinc is bonded with zinc with mercury. The paste of zinc with mercury is called as zinc amalgam. This zinc amalgam behave as anode. In this battery, zinc amalgam behave as anode, and a paste of mercury oxide and graphite. Here the carbon is taken as graphite. The paste of mercury oxide and graphite behave as a cathode. In the small cell, here what is our anode? Anode is zinc amalgam. What is our cathode? A paste of mercury oxide and graphite is our cathode. And the electrolyte is the paste of potassium hydroxide and zinc oxide. The paste of potassium hydroxide and zinc oxide behave as electrolyte for this cell. The electrode reactions are, at the anode zinc amalgam react with, at anode oxidation takes place. So zinc amalgam react with OH minus ions, it will form zinc oxide and water, and electrons are removed. Here the oxidation reaction takes place. So oxidation, what happens? Zinc amalgam undergo oxidation to form zinc oxide. Zinc amalgam undergo oxidation to form zinc oxide, and at the cathode zinc oxide undergo reduction to form zinc. Here the zinc formed again react with, here the mercury formed again react with zinc, it will form zinc amalgam, isn't it? See here zinc amalgam oxidized to give zinc oxide. Here the mercury oxide undergo reduction to form mercury. This will react with zinc to form zinc amalgam again. So this battery is said to be in use until unless the amount of mercury exhaust. Okay, so ಎಲ್ಲಿ ತನಕ ಇರೋ mercury oxide ಇರುತ್ತಲ್ಲ ಅಲ್ಲಿ ತನಕ ಬ್ಯಾಟರಿ ಏನು ಹೇಳ್ಬೋದು ನಾವು, it is said to be working. And we can write overall reaction. We can write overall reaction as zinc amalgam plus mercury oxide gives zinc oxide plus mercury, isn't it? This is the overall reaction taking place in the cell, and the cell potential is around 1.35 volt. As I already said, this battery is used for low current devices, isn't it? So here the potential of the cell is around 1.35 volt. Here the one more important thing is, so during the use of this battery, potential do not change. The cell potential do not change. The cell potential of this battery remains constant, because the overall reaction does not involve any ion in the solution whose concentration can be changed during its lifetime. Here see the reaction during the use of this cell. We cannot find any chemical species or ions who can change their concentration, isn't it? So due to the no change in the concentration of any ions, because we are not using ions here, because of that reason what happens, the potential of the battery remains constant during its use. Okay, so this is about the primary batteries. There are two examples. The first one is dry cell or Leclanche cell. The second one is Mercury cell. These two are the example for dry cells. So in the next class or in the next video, we are going to deal with the secondary batteries. So these are very important. Why? Because for your board examination, one more question will come. What do you mean by primary battery? In such condition, we have to write the definition, isn't it? So for your KCET and NEET examination, they will ask a chemical reaction. Any bit of the chemical reaction can be asked in any examination. Okay, so these chemical reactions are very important. Please remember the chemical reaction and their structure and all the things. Okay, thank you.